Welcome to episode 7, Hazardous Chemical Classifications, brought to you by the Occupational Safety Leadership Podcast. My name is Dr. David Ayers, and let's get started. Hazardous chemical classifications. These are basically found on your chemical safety SDS, your safety data sheet then. So this is where we look down and there's a lot of scientific words and you see a pictogram. And so let's kind of sit down. We'll go over the different pictograms and classifications that you can find. We'll do a couple of practical examples and all that stuff just to help to educate us. This is one of the safety short series. This is not an in-depth conversation, but this is going to be a great starting point for anybody who's really struggling with this concept. So when we look at the chemical classifications, it's broken down into acute toxicity, serious health hazard, oxidizer, environmental, corrosive, flammable, explosive, and then finally gas under pressure. So let's go on to the next slide here. So this first one is probably my favorite one because it has the skull and crossbones. So it stands for acute toxicity. So basically the definition is a substance such as a poison or highly concentrated acid which has immediate and severe toxic effects. So let's look at a couple of examples. And I took these from the semiconductor industry. You have arsenic, chlorine, and diborane. So all of these are considered either poison or highly concentrated acid. This is my favorite one because as the skull and crossbones, the pictograms were added to the safety data sheet since English is not always the first spoken language in workplaces nowadays. So if I didn't speak any English at all, I would look at the skull and crossbones, and at least if I knew nothing else about it, I'd say that's bad. I need to not touch it, not pour it, not smell it. Don't dump it on a table and see what happens. So I would at least know that, if nothing else. So that's the first one when we look at acute toxicity. Let's go on to the next one. The next one is a serious health hazard. This one to me is a little less clear because it just has a person with a exploding substance in a chest. Once again, if I didn't speak English, I would know that is not good. It's not quite as scary as the skull and crossbones. I may be confused. I may not really understand this, but let's look at what a serious health hazard is. The definition is a cancer-causing agent, a carcinogen, or substance with respiratory, reproductive, or organ toxicity that causes damage over time, a chronic or long-term health hazard. So a couple examples out there. We have mercury, lead, ammonia, carbon monoxide, hydrochloric acid, sulfuric acid, and cadmium. I skipped that on the list. I don't think this one is as clear, but if nothing else, it kind of gives you a very good warning of this is not something that you want to touch, smell, dump on the table or anything. Let's go on to the next one. So with this next one, we have what's called a health hazard. It's also a harmful or an irritant. It can sometimes be considered all three and sometimes considered only one out there. I don't find this one to be a very clear symbol. I would at least question it and say, I don't know what this means. I'm not too scared, but I also know that it must mean something because this kind of warning is found on here. So when we look at the definition of either a health hazard, a harmful chemical, or an irritant, what we have is immediate skin, eye, or respiratory tract irritant or a narcotic. And a couple of examples found out in the workplace: ethylene glycol, formaldehyde, chromic acid, and a lot of the petroleum products that you can find out there. This one is not as clear. It would be great if they used a different symbol, but they will not go back and change it now. Let's go on to the next classification. So in this one, we have a oxidizer. So you see the big O for oxidizer and then flames on there. once again, I would say flames are bad. I don't know what this means, but I know it's bad. I know I don't touch it. So the definition of a oxidizer, it is oxidizers are chemicals that facilitate burning or make fires burn hotter and longer. So a oxidizer does not catch on fire, but it does a great job of liberating oxygen. Oxygen, of course, is a key component of fire. So it'll make the fire burn hotter, faster, longer, all that good stuff. And let's look at a couple of examples from the workplace. Hydrogen peroxide, bromine, and nitric acid. So all of these substances are liberating oxygen. Typically, when mixed with something, they typically just don't, for the sake of argument, just liberate oxygen. And so that will make a fire burn hotter, faster, and longer. Let's go to the next slide. Environmental. Here we have a what looks like a dead fish in a river, and it appears like a dead tree to me on there. So I would say, oh, this is not good because I see a dead fish and a dead tree. So let's look at the definition of this one. So environmental are chemicals that are toxic to aquatic wildlife. Let's look at a couple of examples: mercury, nickel, lead, arsenic, cadmium out there. So this is one of the non-mandatory sections that you find on your chemical SDS sheet right now. This could be mandatory in the future, but as of right now, it is not considered a mandatory section on the SDS. And we'll go to the next classification, corrosives. This one is crystal clear to me. So if something is dripping on steel and it's etching down, something is dripping into a human hand and etching down. So they've done a really good job of this one, of letting you know that you are going to get burned. Whatever the substance is, whether it's on the high side for pH or on the low side for pH, you are going to get burned. So the definition is going to be a materials causing skin corrosion, burns, or eye damage on contact, or are corrosive to metals. Many times when something is corrosive to metals, of course, it is making it weaker and everything else. Sometimes it's liberating different things as it's etching down into the steel. Let's look at a couple of examples. And so hydrochloric acid, hydrofluoric acid, sulfuric acid, ammonia, sodium hydroxide. This one is going to be based on the pH of the chemical. So you would have to look on the SDS to really know exactly what that pH is. And like all things, you'd have to know, are you using it as in the form of a mixture? Let's say, for the sake of argument, we're using hydrochloric acid at 37%, or quite possibly we're using hydrochloric acid at 3%, which is commonly found in things to clean bricks and do different things out on a construction site. Or is it something that you're taking your 37% of hydrochloric acid and you're mixing it into other chemicals? So you can also have where when chemicals mix, that it even makes it even etch into the hands or etch into skin even faster. So this is one that we really have to sit down, read, and understand, of course, because we also have to figure out what the PPE that we're going to use. Since not all gloves are going to be chemical resistant, and of course not all gloves are either going to be plastic or nitrile or leather. They don't all work the same. So that's corrosive chemicals. Let's go on to the next one. Flammables. Now this one is different from the oxidizer, which we saw that had the flame. Flammable was just anything that's going to catch fire and burn. So I would look at this and say fire is bad. So flammables. Flammable materials or substances liable to self-ignite when exposed to water or air, a pyrophoric, or which emit a flammable gas. Examples include acetone, benzene, isopropyl alcohol, methyl ethyl ketone. This is going to be based on the flashpoint of the chemical. once again, we have to read and understand that SDS and find out exactly what that flashpoint of that chemical is going to be then. Anything that's, let's say for the sake of argument, I believe isopropyl alcohol has a flashpoint of 56. That's going to be considered a flammable because anything over 56 degrees is going to liberate fumes which can catch on fire. It doesn't mean the fumes will catch on fire, but it means it has that potential of flammable fumes. Vice versa, let's look at some of the drawing a blank now, but let's say for the sake of argument our chemical is going to have a flash point of 256 degrees. In our everyday work environment, we're not going to have a 256 degree place where these fumes and these vapors are being generated. Doesn't mean that we're not trying to make it that. We're heating up the process. We're doing something. But if you were just to have that out on a table at 256 degrees, it's not going to liberate off enough flammable fumes to be considered a flammable. So we have to read and understand the SDS on this one. Go to the next one here. Explosives, to me, it's pretty self-explanatory. It blows up. I may not know how, but at least I know it's going to blow up. So let's look at the example. Explosives including organic peroxides and highly unstable material at risk of exploding even without exposure to air. Anything that's a self-reactive. So when we think about examples, nitroglycerin, TNT, and dynamite, these are not commonly found in the workplace, but that doesn't mean that that we're at a workplace that maybe is not part of a mining operation. You could be doing some geophysical work where you put dynamite charges in the ground, you blast, and then you're looking at your sensors and you're mapping for oil and gas. So these are less commonly found in the workplace. But you do find them in very specialized work environments. Let's go on to the next slide here. Gas under pressure is going to be this last one here. So basically it's going to be a gas stored under pressure, not very descriptive for the definition. But we all know that anything we put inside of a gas cylinder, it's going to have that pressure, that force, has to be handled with care, all that good stuff. And when we think about a couple of common examples out there, nitrogen, ammonia, propane, you can think of CO2 if you're dispensing beverages, helium is out there. So there's going to be a lot of different gases stored under pressure then. So they come in all shapes and sizes, so you can't just look at a cylinder and say it only counts as hazardous if it's over 3 feet tall and 6 inches wide. The big hazard is going to be the pressure, and the secondary, of course, is obviously going to be whatever was contained inside that compressed gas cylinder. And that's it for episode 7, hazardous chemical classifications. That was just a very quick safety short just to help us understand a little bit about the commonly found pictograms and classifications we can find on the chemical safety data sheet. So this safety short was brought to you by the Occupational Safety Leadership Podcast. Please do everything you can to subscribe to my YouTube channel, to my podcast, where more of these safety shorts are going to be posted in the near future. This is episode 7, and this was brought to you by Applied Safety Management. My name is Dr. David Ayers. Thank you so much, and have a safe day.